In today's video, we're going to learn a thing or two about standard electrode potential. Now before I go and further elaborate what is in this part of the chapter, you guys need to know the differences between a galvanometer, an ammeter, as well as a voltmeter. Galvanometer, it is used to measure small currents. Now normally ammeter cannot detect small currents, so we need to use galvanometer. So in YouTube kan, we use a galvanometer, not ammeter, because the current produced from the redox reaction that is in the YouTube is very small. So that's why we're seeing right now standard electrode potential, the guna voltmeter. So for standard hydrogen electrode, our goal is, which is under this standard electrode potential ni. So standard hydrogen electrode, but we just make it as HE for short. Our goal is to know how much voltage that can be produced to know when we pair different types of metal together. Because we already know that if pair different metals, there will have a current flow. But we want to know how many energy that can be that is produced. Standard electrode potential, here's a few side notes. So in SPM, we are just focusing on the metal half cell. Now the metal and metal ion must be the same. And what do we mean by this? This is referring to the half cell. Okay, so what is a half cell? A half cell is a combination of a metal with a solution that contains the metal ion. For example, if we have, it's a combination, kan tadi tu the definition is combination of metal. Nampak tak ada metal, magnesium, magnesium is a metal, right? So magnesium metal kat sini with a solution that contains metal ion, but it must be the same type macam ni. Dia contain metal ion solution, but it must be the same type. So yang ni magnesium, yang ni pun magnesium, tapi apa beza dia? Yang ni magnesium ion, so it's a metal ion solution. Okay, macam ni dia salah, it's not a half cell. Sebab yang ni dia guna zinc metal, tapi dia punya solution dia guna metal ion, which is aluminium. So tak sama lah. Okay, so it's not a half cell. Now the question that occurs next is what happens in a metal half cell? So there are two processes that are about to happen. What happens is this metal yang magnesium ni, dia akan lose electron to become a metal ion. Remember, when you form your half equation, you add your electron at the more positive side. So yang ni Mg2 plus kan, so you add 2 electron. So another process that happens is the metal ion in the solution, dia akan gain electron to become a metal. So just now we have the magnesium 2 plus ion tu kan over here as a solution. What happens is bila yang ni yang dia release electron ni, this will eventually attract it. When it gains electron due to the attraction tu, dia akan form magnesium metal or magnesium atom. Bila ada process of donating and receiving electron, what happens is electrons are moving, right? That's proof that berlakunya pergerakan electron, and then electricity will be produced. Kenapa electricity is produced? Sebab when electron is moving, electricity is produced, and that's the logics of it lah. Okay, so half cell they produce electricity because the metal kan dia donate electron, but the metal ion dia receive electron, so berlakunya pergerakan electron from there. Okay, the donating and receive. Bila ada satu donate, satu receive, also this just prove that a redox reaction is happening, because bila dia gain electron, dia undergo reduction. Bila dia lose electron, dia release electron ni kan, so dia lose electron, so berlakunya oxidation. So from there we also know bila dia gain electron dia kan reduction, so yang ni is the oxidizing agent, whereas yang ni dia lose electron, so dia undergo oxidation, so this is the reducing agent. The amount of electricity produced by the half cell becomes the standard electrode potential. We know half cell produces electricity. The problem is, how do we measure the amount of electricity produced by the half cell? And we know the electricity produced by the half cell is also known as the standard electrode potential. The way to measure the standard electrode potential is to actually connect it to a standard hydrogen electrode. So this is the one yang I kata short for SHE. So how does a standard hydrogen electrode look like? It looks like this. So you have your beaker, then you have your H solution, a solution that contains H plus ions, and then you have your electrode, but we use a platinum electrode, but we use sikit je, so actually just draw kecil pun tak apa, Sikit kenapa? Because it's expensive, okay? And we have this wire, and then dia ada macam opening. This opening can be on the left, or it can be on the right, macam ni. Hydrogen gas enters. Standard condition for a standard hydrogen electrode is number 1, to make sure the electrode we use is a platinum punya. 2, temperature must be 25 degrees or 298 Kelvin. Now to measure in Kelvin, right, if you take physics, 25 ni kena plus dengan 273 to convert it into Kelvin punya unit. The pressure must be 1 atmospheric pressure ataupun also known as 101 kPa. So if you turn it into PA, it's actually 101000. Then the concentration of the H plus ions over here must be 1 molarity or 1 mole per dm cube. So tanya, draw an apparatus set up to measure the standard electrode potential for an aluminium half cell. Draw as macam biasa what we learned. So this is the standard hydrogen electrode, and this is the standard electrode potential. No, sorry, this is the half cell. And then electricity produced is the standard electrode potential. You connect it macam biasa, then a wire is connected to a voltmeter so that dia boleh measure how much the voltage is. Tapi difference is, something to take note is ada salt bridge. And what is a salt bridge? A salt bridge is basically to allow ions to pass through to complete the circuit. Salt bridge can be made out of sulfuric acid, diluted sulfuric acid, or it can be out of soluble salts. So in SPM questions, normally they would give us equations and values for the standard electrode potential. So you do not need to memorize this, you just need to know how to utilize this. When we read the E0 value that is given, 0.76 V, right? So here we know that the zinc half cell over here will produce 0.76 volts when it is connected to the standard hydrogen electrode. So when it is more negative, maksudnya dia sebenarnya dia higher reducing agent. Sebab reducing agent is basically when the E0 value is more negative or less positive. Okay, so half cell copper, dia akan produce 0.34 volts. And what else happened? It's a better oxidizing agent as opposed to being a reducing agent. Okay, so oxidizing agent dia kena more positive atau less negative. Next, so if someone tanya which is the stronger oxidizing agent, we need to compare, okay, the E0 value between these two. So oxidizing agent, kita nak benda tu more positive, right? So it is this one. Maksudnya, now the question that might occur to you is, hey Rania, how would you know it's silver ion or is it silver metal to choose from, right? So the answer to that is, when they ask for oxidizing agent, now you have to split it into two. If they ask for reducing agent, you look at the right side, but now they ask for the oxidizing agent, so it's the left side. And how to memorize this? You have to view it like or, like the word or. So left side is the oxidizing agent and the right side is the reducing agent. Ta-da! So the more positive value of the E0, the more easier it is to receive electron. The more easier it is to undergo reduction because you receive electron kan. So the more stronger oxidizing agent it will be. Now think of it logically pun, when it's more positive, when there's more macam electron kan. Sorry, not electron. When it's more positive, right, it's easier to attract negative, and negative comes from the electron. Tapi tak payah fikir panjang sangat, just note that kalau left side oxidizing, kalau right side reducing. And oxidizing, think of it like positive, more positive atau less negative. Yang ni more negative atau less positive. Okay, moving on. So diorang tanya which is the stronger reducing agent, kita tengok balik. Reducing agent kan or kan. So reducing agent is on the right side, so it's either magnesium or zinc. But reducing agent is more negative, so kita tengok, kita bandingkan daripada dua-dua ni, we dapat tahu, okay, this one it has a higher value of a negative number, so it will be magnesium atom. And kalau boleh, please do specify whether it's an atom or an ion. Moving on, so given these things, arrange strength of oxidizing agent in ascending order. So we know oxidizing agent kan belah kiri, left side, and we know that it has to be more positive. The most positive one, the most highest positive value of a number then that one has the highest oxidizing strength, because oxidizing agent punya strength, because oxidizing agent kan dia kena more positive atau less negative. So most positive kan ascending order, so yang paling kecil mana? Yang ni. Middle ni pada ni. So 1, 2, 3. Tak payah tulis the ratio, okay, when you list it down. So it's just zinc 2 plus ion, then the hydrogen ion, and copper 2 plus copper 2 ion. Okay, next. Arrange the strength of reducing agent in a descending order. So reducing agent is on the right side, so it cannot, jangan pandang sini dah, it can be either one of these 3. So reducing agent, dia nak strength in descending order. Which one is the highest reducing agent? So the most negative is this one, descending order kan. So yang paling besar yang ni for reducing agent punya strength. Middle ni, last yang ni. So reducing agent, the stronger it is, the more negative it is, or less positive. So more negative yang ni lah. Okay, so zinc, hydrogen, then copper. Ta-da! So to find out whether or not a reaction occurs between these two, we have to compare the copper. And since the reaction is between copper and silver nitrate, so we have to compare the copper, and since there's no nitrate here kan, so we just take the silver ion. It's considered silver ion lah kan. So tengok silver ion berada dekat the left side, and the left side is oxidizing agent and the right side is reducing agent, right? So silver ion kenalah stronger oxidizing agent, and if we tengok ion, it must be higher E0 value, so it is a strong oxidizing agent, whereas copper dia kena strong reducing agent, so maksudnya dia kena less positive atau a more negative E0 value, and in this case it is less positive, so it is a strong reducing agent. So reaction does occur between them. Alright, so predict whether a reaction occurs between this. Oh my god, this seems super complicated, right? But don't worry, because as you notice, okay, step 1. First, let's notice the whole, this thing itself. Okay, it's an ionic equation. But remember, in this chapter specifically, half equation is basically the king. Okay, so you turn it into half equation. So satu dapat yang ni, satu lagi dapat yang ni. Okay. And because we're focusing on the reactants, right? So we're focusing on this as well as this. Okay, so we have the chloride and also the what is this? Dichromate ion, I think. Yeah, it is. Okay, so usually it's already given in your list over here. So you just tengok aja yang ni. Okay. But yang ni, okay. Mula I arrange it like this style, but then I guess some people will question like, hey, how would you know? It's also based on the jadual actually, so just tengok jadual je, and you kena ikut this way. So macam if you notice, all the electrons semua belah kiri, like before the arrow over here. Okay, so arrange it this way. So from there, and value usually semua dah given, okay, so don't panic. So from there kita boleh compare. So we know we're dealing with these two reactants, right? And nampak tak, satu belah kiri, satu eventually dia lies on belah kiri, tapi satu dia belah kanan. So now we know which one is supposed to be the oxidizing agent and which one is supposed to be the reducing agent. So sekarang, to predict whether a reaction occurs, dia kena ada one strong oxidizing agent and one strong reducing agent. So right now, oxidizing agent kat sini. It must be more positive compared to the other half equation, right? So kita tengok kat sini. Is it more positive? No. Tak. So there's no strong oxidizing agent. From there, a reaction terus tak occur. But okay, let's tengok the reducing agent. The reducing agent is patutnya ni kan. Is it more negative? Tengok. Yang ni lagi besar dia punya value. So therefore, they have weak oxidizing agent and weak reducing agent. So a reaction does not occur. Ta-da! So easy, right? Now let's try last question, and we're pretty much done with standard electrode potential. Okay, so this soalan pula, predict whether a reaction occurs or not. First, identify your two reactants. this one and this one. So we have bromide and we have hydrogen peroxide. Where are you? Where are you? Here. You're here. So tulislah benda ni and you dah beritahu E0 value. By the way, I forgot to mention. So if your E0 value of the half cell is positive, maksudnya it's connected to the positive terminal. So if it's a negative, then we know it's connected to the negative terminal. Value ni pun shows us the strength of the oxidizing agent or reducing agent. We're gonna just write this down over here. So here, ada kat sini. Now next one is bromide. So we're going to compare that here. Mixture sama, okay. So it turns into bromide ion. Okay. So tulisan ni. But make sure you think on the jadwal, you follow the jadwal. So the electron must be on the left side before the arrow, okay. So now we can identify that kalau hydrogen peroxide ni, dia sebenarnya our oxidizing agent. Sebab dia berada di left side. Remember OR. Whereas the bromide ni, it's referring to a reducing agent because it's belah kanan. Will a reaction occur? Let's view it. So macam because yang ni kan dia oxidizing agent, kita kena make sure dia lebih positif. So tengok E0 value dia and compare it. See, it is more positive. Value dia lebih tinggi. So it is a strong oxidizing agent. Let's say on the reducing agent, is it more negative or less positive? Yes, it is less positive. No, bilangan apa dia punya nombor lagi kecil. So it is a strong reducing agent. So tada! A reaction does occur, a reaction does take place. So that is all for standard electrode potential. I hope you guys understand what I'm trying to convey in today's video. If you guys have any questions, do comment down below or send me a DM. Bye!